Alright students, so for those of you who finished the quiz, I'm going to give you a head start on what we are going to do today. And I have the same question. I messed up right here, let me fix this. Should say 3. So I'm going to go to Walmart after school today, and there are 3 methods of transportation. The first one is, let me get a different color. Sorry about that. There's a 3 out of 10 chance that I would take the orange line. So I'm going to go ahead and number that as 3, as 1. There is a 5 out of 10 chance that I would take the 11, and a 2 out of 10 chance that I would take the 9 or 1. So again, just like we've done it before, 2 and 3. So I know that my options for transportation are going to be, and I'm just going to write it right here, super short, are going to be the orange line with a probability of 3 out of 10, the 11 with a probability of 5 out of 10, and the 901 with a probability of 2 out of 10. And of course you can simplify these, but I'm not going to simplify this right now because I just want to get to the main work of today. Second, almost the same thing, is I also know the probability that I'm going to see a student. And there is a 3 out of 5 chance that I will see a student and a 2 out of 5 chance that I will not. So if I want to number these, 1, 2, over here I'm going to write student. Yes would be a 3 out of 5, and no would be a 2 out of 5. Again, I'm modeling what you should essentially be doing on your own to organize your work before you get started. So what we're going to learn today is called the probability tree, and it's very similar to the area model, except it gives you a better visual representation of what all the probabilities are. And here's the basic idea behind it. So I'm always going to start off with a point. From here, I'm going to move on to my first event, and in this case, my first event is going to be transportation. So I have 1, 2, 3. Where at the tips of it, I'm going to have either the orange line, the 11, or the 901. Now to organize your work even more, I already know that the orange line is going to be 3 out of 10. The 11 is going to be 5 out of 10, or 1/2. And the 901 is going to be 2 out of 10, or 1/5. Remember, we simplified these last class, and you do now. So I got the first event down. The second event is going to be the students. So for each one of these, I'm going to have a yes and a no, yes, no, yes, no, yes, no, yes, no, yes, no. And I also know that if I make this, for the yes it's 3/5, 2/5, 3/5, 2/5, 3/5, and 2/5. Let me get this on the screen. So what is the purpose of this? Why is this a little bit different? We'll go ahead and stop the video, and I want you to submit your answer in EduCanyon. Perfect. Now that you did that, the main difference with this is that you can actually show all the representations. So if I'm going to look at, if I follow this branch right here, this is going to be the orange line, and this is going to be the yes. So this one right here is going to represent the probability that I take the orange line and that I see a student, which in this case is going to be the orange line 3/10 times 3/5, and I am going to get 9 out of 50. Similarly, let's pick another random one. I can take the 11 and no. So this n right here is going to represent the probability that I went on the 11 and that I did not see a student. Let me finish this. The probability that I took the 11 is 1/2. The probability that I don't see a student is 2/5. So the probability that I take the 11 and do not see a student is going to be 2 out of 10, or 1/5. So again, to summarize this and to put it into perspective, the main idea behind this is that I can follow any track, any branch to get my final probability. This is a really good way if you want to show all your different samples, because then you know that this one right here, oops, let me go back. For example, this one's going to be the probability that I do take the orange, do not see a student. This one's going to be the probability that I take the 11, I do see a student. Probability that I take the 901, see a student. And probability that I take the 901 and do not see the student. So you can already tell that one great advantage to this model is that you can see all the probabilities. It's might be a lot simpler than the area model, but it also has one other advantage that I kind of want you to figure out by yourself. So at this point, go ahead and continue working on the quiz and go back to that extra problem that I gave you. I believe it was number 3, and see if you can create an area model using this lesson.